Alrighty guys, so we have lesson 5-4 in our Envisions book. We have represent and graph ratios. So we can solve ratio problems by using tables and graph to show equivalent ratios. Okay, so first is the solve and discuss. As always, you guys can pause the video, try it on your own, and then compare answers to what I would have. Okay, so you can kind of use the table here to help you with this. We kind of did this with our other, like our double number line. And as we can see that each one up here increases by 4 each time, we can take that same ratio and use that 3 and increase each one of these by 3 each time, to kind of figure out what our ratios would be from number of adults to children at the beach. You can also take this information here, and this would be, we talked about this last chapter, that the top variable is going to be your dependent, while your bottom one is your, or actually, sorry, this is your independent to your dependent. So our x and our y, so our ordered pairs would be 4, 3, 8, 6, 12, 9, 16, 12, and then 20, 15. And then you could graph these as well as our relationships here. So we have 4, 3, we have 8, 6, 12, 9, 16, 12, and then 20, 15. And when we graph these relationships, we should see that they form a straight line for the most part. But we have a straight line as our relationships go, showing that these are very linear relationships. Now the last question here says if there were 25 children and 15 adults at the beach. Emery says that there are 5 children for every 3 adults. Is he correct? Well, if I have 25 to 15, I would want to see if that is an equivalent ratio to 5 to 3. Well, and if I divide both of these by that 5 to make it, I would get that 5 to 3. So yes, he is correct. All right. So we're going to jump right into our first example here. So we're exploring ratios in tables and graphs. So again, we have Ellen is shopping for supplies at Jake's party store. Make a table to show how much Ellen would spend to buy 3, 6, and 9, and 12 balloons. Then plot the pairs of values in the coordinate graph and use the graph to find the cost of 18 balloons. All right. So we have our balloon cost here. So it says 3 balloons is $2. So that's the ratio that we would want to start off with. So we also want 6, 9, and 12, since that's what it says in the problem here, to kind of build our table. But luckily here we can see that these are all increasing by 3, so we can use our ratio again. That if I have 6 balloons, it should cost me $4. If I have 9 balloons, it should cost me $6. And then if I have 12 balloons, it should cost me $8. So now I have my ordered pairs again. This is my X, this is my Y. Okay. Now I can develop the ordered pairs that we're going to use for our problem. Okay, so then this is, in my graph, this is the number of the balloons, and this is the cost. Okay, and put a title, cost of balloons. All right, so I have 3, so 1, 2, 3. Plotting my points on here best that I can, seeing my pen will work the right way. And we have a nice straight line. if our line continues, we should be able to kind of, if we have it a nice straight line, it should work out where we could just look over here at 18 and follow that line up. That's kind of where we should go, yeah. So it should hit our line. If my line was a little, if I could draw a straighter line, it would fit right there. But at 18, we would have 12 balloons. Or yeah, 18 costs, yep. Or $12, sorry. Okay, all right. Here again is your try it. Go ahead and look at your try it and check back with me in a moment. So pause your video now. All right, so you first with the try it, you could look at your graph here at $9 and then $6 there comes across or your $6, then you can come down to 9 to find that this is the ordered pair that would represent the balloons you can buy for $6. And then they convince me, it says you can find 15 on the x-axis, then go straight up until you reach the line and find the corresponding y value, which is 10 if I'm looking at 15. So the cost of 15 balloons is $10. All right, so here's another example that we have here. So Jack is making juice. He has 25 celery sticks. If Jack uses 25 celery sticks, how many apples will he need to make the juice? All right, so here is his, we have 5, 2. All right, so again, like our double number line, we can increase each side. So we increase this side by 5 each time. So increasing all the way using our table to get to 25. And then if this side's increasing by 2, well then this side has to, or by 5, this side has to increase by 2 over here. So 2, 4, 6, 8, and 10. All right. Again, we have nice values here that we can use to plot our values. This is our x, this is our y. So we have our celery sticks, and then our apples. And we can also relate our ratios here to our table and to our graph. So we're going to go ahead and plot all these points as well. So we have 5, 2, 10, 4, or at least as many as we can. We're going to run out of room on this graph. And there we go. So we can see if we look at our nice line here that we're kind of each side over here, we're going up 5, and then we have up 2, up 5, and up 2. So notice that even in the graph, it still follows that same pattern that the table provided for us. That they all relate, they all have a relationship together. All right, so then let's look at another one. This one looks like we're looking at some subtraction here. So Tyrese lives 10 blocks from the library. He walks 3 blocks every 2 minutes towards the library. How far is he from the library after 5 minutes? All right, so let's kind of start with our time is going to be 0 if we're 10 blocks away. And if we look at our ratio here, so this one starts a little bit differently because we're kind of going backwards. We're going to be subtracting. So we have to have our starting point here where we're not starting from like almost 0, we're working backwards. So our time is increasing by 2 minutes, but then our blocks here, getting home here, is subtracting our 3. Okay, so if I have my 2 minus 3 is 7, my 4 minus 3, 4, we have 6, and then we subtract 3, 1, and then we're going to, if we went any further, we're going to get a negative zone, and we don't want to pass our house or pass the library, we want to get there. All right, so let's kind of see if we can use the graph then to really help us, because they're asking for that 5 minutes, which you can tell by our table we didn't exactly find a nice solid number there on our table. So let's use our graph to kind of help us. So let's start at 0, 10, then we have 2, 7, we have 4, 4, and we have 6, 1. All right, so now we have our nice line, and if we try it, like I said, make them at your lines as straight as possible. It's a little difficult for me on how the computer is set up in my pen. Yours might be a little better and straighter here, but after 5 minutes, let's see if I can do a better job. It's a little bit better. So after 5 minutes here, so we're about right here, which would mean 1, 2.5. So we're about 2.5 blocks from the library after 5 minutes. So when you're looking at these tables, guys, it's really important to try to give it the best line so you can have the most accurate answer. All right, so this leads us back to our key concept and our do you understand. So go ahead, guys, kind of look at your key concept and answer your do you understand questions, and then just go ahead, pause the video so that you can take a moment to do those. All right, here you guys go. You can kind of look at my answers here, but you can use repeated addition or subtraction to complete your tables and plot your values. And then for number 2, and then here's number 2. So place a point at 1, 3, and then go right 1 and then up 3 to get to your next point. We did this or looked at an example of this really in example 2. So just like here, we were adding 5 in our table, we were just going right 5 up 2, right 5 up 2, just like our table. So that's where that question comes from. All right, go ahead and start your working on your homework.